13 says, what volume is occupied by a 53.25 gram sample of chlorine gas at 20 degrees Celsius? 20 degrees Celsius information lets you know that the gas is at a temperature where the rules of moles and liters work. So this is not a number that gets used. It's just to say that the conditions under which the measurement was made works. There's no conversion involved. So, how do we go about tackling this problem? Well, the first thing to realize is that chlorine gas is Cl2. Remember, it's a diatomic. So Cl2, if you're going to solve for the molecular weight, you look up Cl, chlorine. Each atom is 35.4, but there are two of them. So you got to multiply it times 2. And this will give you a 70.8. Now what is that? That is the AMU, or molecular weight. So it's atomic mass units, it's the molecular weight. Let's now set up our ratio. The ratio of this is going to be that 70.8 grams is going to be 1 mole. Again, remember, 70.8 AMUs is the weight of one single chlorine molecule. 70.8 grams is the weight of an entire mole worth of chlorine gas. So once we know that's our ratio, we can set up our proportion. 70.8 grams of Cl2 is 1 mole. But I don't have 70.8 grams. The problem says I have 53.25. So 53.25 grams of Cl2 is what I have. And what I'm asking for is, so how many moles is that? We would do the cross multiplication, and it's going to give you 70.8 grams Cl times X moles is going to equal 53.25 grams times 1 mole. When you do the algebra, X is going to equal 0.75 moles of Cl2 gas. But you know what? That's not the answer. It's part of the process to get to the answer. You see, let's go back to the question. The question is asking you, what is the volume occupied by this much gas? What you just solved for was the amount of moles of gas this represents. If you know the number of moles, you have to now go and convert to liters, because that's the volume you're looking for. So let's remember, so let's remember this number, 0.75 moles of Cl. I've run out of space. So X was equal to 0.75 moles of Cl2 But now the question is, how much volume is that? Well, we got to build a new proportion. Oh, my bad. We got to build a new ratio. What would that ratio be? Well, the ratio is going to be that 1 mole of Cl2 is going to occupy 22.4 liters. That is a unit ratio. Now we can build our proportions. In our proportions, we're going to write down that 1 mole of Cl2 is 22.4 liters. So, how many liters is 0.75 moles? If you cross multiply, you wind up with 22.4 liters times 0.75 moles. It's right here. That equals 1 mole of Cl2 times X liters. When you work out the algebra, you wind up with 16.8 liters equals X. Now that is the answer we were looking for. Let me show you something you need to think about. The issue is 16.8 liters, is it reasonable? That's a good question to always ask. Is this reasonable? Well, according to our calculations beforehand, we said that there were 0.75 moles of chlorine gas. I know 1 mole occupies 22.4 liters, but this is less than 1 mole. So you would assume that the number of liters would be less than 22.4. And it is. So this is a reasonable answer to the calculation.